Hello everyone, and welcome back to another episode. Today we're exploring something many of us have in our homes and throw away every day: banana peels. That's right. Those yellow skins sitting in your kitchen trash might actually have a place in your garden and can benefit your plants. In this episode, we're going to explore the science behind banana peels. We'll look at the nutrients inside them, how long they take to break down in soil, several ways growers utilize them as fertilizer, and how this delicious fruit can even be used as a pest repellent. But before we begin, please remember that this is an educational video, and all information provided is for educational purposes only. Now let's get into it. Picture this. Every year, humans consume over 100 billion bananas worldwide. And nearly every single one of those bananas leaves behind the same waste product, the peel. Most people toss them into the trash without a second thought. But to a gardener, a banana peel is far from waste. It's actually a concentrated source of organic matter and plant nutrients. And when used correctly, those nutrients can contribute to soil health and plant growth. But before we start burying banana peels in our gardens, let's take a closer look at what's actually inside them. Now that we've covered some background on today's topic, I want to take a moment to thank the sponsor of today's video, Spider Farmer. Since 2009, Spider Farmer has been building indoor growing equipment ranging from grow tents and LED lights to ventilation systems, environmental controls, and equipment designed to make managing the entire grow space easier. One way that I think Spider Farmer products can really benefit growers is by helping them streamline their operation. And the product that I think really goes a long way in helping people do that is the Spider Farmer GGS Grow Tent Climate Controller Kit. Using a series of specially designed sensors, this system gives you real-time information about what is happening inside your grow space. Right from the controller, you can monitor temperature, relative humidity, VPD, and the current light cycle. And to make it even better, through the Spider Farmer app, you can also monitor and control compatible equipment remotely, giving you a much easier way to manage the environment without constantly making manual adjustments. Another interesting product is Spider Farmer's 6-inch 2-in-1 ventilation system, which combines an inline fan and carbon filter into one compact unit. Instead of installing the fan and filter separately with additional connections between them, the system combines both into a single design to help simplify the ventilation setup while providing air exchange and odor control. One final product that I think can be really helpful for anyone looking for more control over their grow is the Spider Farmer GGS 3-in-1 Soil Sensor Pro. This dynamic sensor system monitors soil moisture, soil temperature, and electrical conductivity, giving you a better understanding of what is happening around the root zone. Instead of relying only on how the soil looks or feels, you can use real-time data to help make more informed decisions about watering and nutrient management. In addition to sponsoring today's video, Spider Farmer is offering our community a special promo code. Make sure to use code CannabisGuy at checkout for 8% off your purchase. I'll leave links for the GGS Grow Tent Climate Controller Kit, 6-inch 2-in-1 ventilation system, and the GGS 3-in-1 Soil Sensor Pro in the description below. Thanks again to Spider Farmer for sponsoring today's video. Now let's get back to today's topic. Chapter 1. Nutrients inside banana peels. Banana peels are surprisingly rich in plant nutrients. While they aren't a complete fertilizer on their own, they do contain several elements that cannabis plants rely on throughout their life cycle. As many of you already probably know, the most well-known nutrient in banana peels is potassium. Like all plants, banana plants require potassium to regulate water balance, enzyme activity, and sugar transport. As the banana fruit develops, potassium is distributed throughout the fruit and its protective outer layer, the peel. Inside the peel, potassium exists primarily in water-soluble ionic form within the plant's cells. This potassium helps maintain cellular pressure, regulate metabolic reactions, and support the transport of carbohydrates produced through photosynthesis. Because bananas are fast-growing plants that produce large, energy-dense fruit, they accumulate relatively high levels of potassium compared to many other fruits. For cannabis plants, potassium is particularly important during the flowering stage, when plants must move large amounts of carbohydrates from the leaves to developing buds. Without adequate potassium, plants may struggle to regulate water balance, leading to weak growth and poor flower formation. Banana peels also contain phosphorus, which the banana plant absorbs from the soil as phosphate ions through specialized transport systems in its roots. Phosphorus is essential for energy transfer inside the plant because it is a key component of adenosine triphosphate, also known as ATP, which is the primary energy molecule used by all living cells, including cannabis plants. During the early stages of a plant's life, phosphorus plays a crucial role in root development and early establishment. When a cannabis seed germinates, the first structure to emerge is the radicle, which eventually becomes the plant's primary root. Adequate phosphorus during this stage supports the growth and expansion of the root system, allowing the young cannabis plant to anchor itself in the soil and efficiently absorb water and nutrients. As the plant matures and transitions from vegetative growth into the flowering stage, phosphorus continues to support growth, but its role shifts toward reproductive development. Phosphorus helps drive metabolic pathways involved in energy transfer, carbohydrate movement, and genetic replication. Because it is a structural component of DNA and RNA, phosphorus is directly involved in the formation of new plant tissues associated with flowers and seeds. It also helps move sugars produced during photosynthesis from the leaves to developing buds, supplying the energy needed for dense flower formation and cannabinoid production. Another nutrient found in banana peels is calcium. In soil, calcium typically exists as dissolved calcium ions that originate from weathered minerals, decomposing organic matter, or natural soil amendments such as limestone. The roots of the banana plant take up these calcium ions through specialized transport proteins located in root cell membranes. Once inside the plant, calcium is transported through the vascular system and incorporated into various tissues, including the fruit and its protective peel. Calcium plays a critical role in plant structure and stability. One of its most important functions is strengthening plant cell walls. Calcium binds with compounds called pectins, which can be found in the middle layer between plant cells. They help glue neighboring cells together and maintain structural integrity. In cannabis plants, calcium is especially important because it supports rapid cell division and tissue formation. When new roots, stems, and leaves develop, the plant must constantly build new cell walls. Calcium is also involved in cell signaling by acting as a messenger that helps plants respond to environmental changes such as drought stress, temperature fluctuations, or pathogen attacks. Through these signaling pathways, calcium helps regulate growth patterns and defense responses, contributing to the overall resilience of the plant. Banana peels also contain magnesium. In soil, magnesium typically exists as dissolved magnesium ions that originate from weathered minerals, organic matter, or natural soil amendments such as dolomite. Magnesium plays a critical role in plant physiology because it sits at the center of the chlorophyll molecule, which is the green pigment responsible for capturing light energy during photosynthesis. During photosynthesis, chlorophyll absorbs sunlight and converts that energy into chemical energy that the plant can use to produce sugars. These sugars ultimately fuel plant growth and development. Without sufficient magnesium, the plant's ability to perform photosynthesis becomes compromised. In addition to these macronutrients, banana peels contain other trace elements, such as manganese, iron, copper, and zinc, which contribute to enzyme activity and metabolic processes within the plant. While banana peels won't replace a balanced nutrient program, they can certainly contribute beneficial elements to soil over time. But that leads us to an important question. How long does it actually take for a banana peel to break down and release those nutrients? Chapter 2. Decomposition time of banana peels. When organic materials enter the soil, they don't immediately release nutrients. Instead, they must go through the process of decomposition, which is driven by microorganisms such as bacteria and fungi. Banana peels are composed mostly of water, carbohydrates, and plant fiber, which makes them relatively biodegradable when compared to other materials. Under ideal conditions in a compost pile, banana peels can break down in 2 to 5 weeks. However, when buried in garden soil, decomposition may take around 1 to 3 months and is dependent upon soil moisture, microbial activity, temperature, and oxygen availability. Chapter 3. Different ways to use banana peels as fertilizer. There are several different ways to use banana peels in your grow setup, and each method affects how quickly nutrients become available to the plant. One of the simplest approaches is banana peel tea. This method involves soaking chopped banana peels in water for roughly 24 to 48 hours. During this time, the minerals within the peel dissolve into the water, creating a mild liquid fertilizer that can then be used to water your plants. Banana peel tea primarily supplies potassium and trace minerals, making it especially useful during the flowering stage when cannabis plants demand more potassium for bud production. Another common method is composting. Banana peels are considered a green compost material, meaning they contain relatively high nitrogen compared to dry organic matter. When added to compost piles alongside brown materials such as dried leaves, cardboard, or straw, banana peels help stimulate microbial activity and accelerate decomposition. Under healthy compost conditions, banana peels break down in about 2 to 5 weeks, depending on factors such as temperature, moisture, oxygen levels, and the overall balance of green and brown materials in the compost pile. Warm, well-aerated compost systems with active microbial populations will break down banana peels much faster, while colder or poorly managed piles may take longer. During this process, microorganisms such as bacteria and fungi digest the organic material in the peel. As they do so, the peel's plant fibers, sugars, and minerals are gradually broken down into simpler compounds. These compounds are then incorporated into the compost as microbes convert the material into humus, a stable organic substance that improves soil structure, water retention, and nutrient availability. Many growers consider composting to be the safest and most balanced way to recycle banana peels into cannabis soil, because the composting process allows microbes to stabilize the nutrients before they are added to the grow medium. This reduces the risk of pests, odors, or nutrient imbalances while producing a rich soil amendment that supports long-term plant health. A third method is drying banana peels and grinding them into powder. When banana peels are dehydrated and crushed into small particles, they become a dry organic fertilizer that can be stored for long periods. The powder can be mixed directly into soil or sprinkled around the base of cannabis plants as a top dressing. There are several simple ways to dry banana peels. One of the most natural methods is sun drying. To do this, cut the banana peels into smaller strips and place them on a tray or screen in direct sunlight. In warm, dry conditions, the peels will typically dry in 2 to 3 days. Turning them occasionally can help ensure they dry evenly. Another method is oven drying, which is faster and more consistent. Simply cut the peels into small pieces and spread them out on a baking sheet. Place them in an oven set to a low temperature, usually around 200 degrees Fahrenheit, and allow them to dry for about 1 to 2 hours, or until the peels become brittle and snap easily. Some gardeners also use food dehydrators, which provide steady airflow and low heat. In a dehydrator set between 125 and 135 degrees Fahrenheit, banana peels typically dry in about 6 to 12 hours, depending on their thickness and moisture content. Once the peels are completely dry, they can be ground into powder using a blender, coffee grinder, or food processor. The resulting powder is easier for soil microbes to break down because the particles are much smaller than whole peels. As microbes decompose the powder, nutrients are gradually released into the soil, making them available to your plants over time. Chapter 4. Banana peels as a pest deterrent. Beyond their nutritional value, banana peels have also been explored as natural pest deterrents in the garden. While they are not a guaranteed solution for pest control, some growers use them as a small part of an organic pest management strategy. One group of pests that banana peels may help discourage are aphids, which are small, sap-sucking insects that feed on plant juices and are attracted to tender new growth. They can quickly multiply, ultimately weakening plants and spreading plant diseases. Some gardeners bury small pieces of banana peel near the base of plants to help deter aphids. Banana peels may also have some influence on ants, which are often closely associated with aphids. Ants protect aphids because they feed on the sugary substance aphids produce, known as honeydew. By disrupting aphid activity or altering the chemical environment around the plant, decomposing banana peels may indirectly reduce ant activity in that area. Ultimately, banana peels should be viewed as a minor supporting tool within a broader integrated pest management strategy. In this way, banana peels may play a small but helpful role in supporting a healthier garden ecosystem, where plants are better able to defend themselves naturally. And that brings us to the end of today's episode. As we've seen, banana peels aren't just kitchen waste. They contain valuable nutrients like potassium, phosphorus, calcium, and magnesium that can contribute to soil health when used properly. Whether they're composted, brewed into tea, dried into powder, or even used as part of a pest management strategy, banana peels offer growers another simple way to recycle organic materials back into the garden. If you enjoyed this episode, give it a thumbs up, subscribe to the channel, and tap the notification bell so you never miss a new video. And we'd love to hear from you. Have you ever used banana peels in your cannabis garden? Did you compost them, ferment them, or try banana peel tea? Let us know in the comments below. Thanks again for watching, and until next time, keep being awesome and stay curious, my friends.